All right, guys, this video is the first video I'm going to do for the last section of chapter 12, Inference for linear regression. This this section focuses on slopes of scatter plots. Basically, we're going to look and see do two variables have a relationship with each other? Because if two things have a relationship with each other, then their slope is affected. We'll talk about that more in the section or the second video that I make for this section. The biggest thing is that there are 5 conditions instead of 3. We're used to random, normal, and independence being the 3 conditions we check for. But now we have 5. The 2 new ones are linear. Obviously, if you're doing stuff with scatter plots, the variables need to be linear. They can't be curved. They can't make like a parabolic shape or something like that. So you have to check and see if it's linear. You also have to check for equal variance. And equal variance means that the spread of the dots around the regression line needs to be pretty similar. For example, in the exercises on page 759, this would be an example of non-equal variance. Notice that at the beginning of this residual plot, the points lie close to the line, and then they kind of fan out like in a trumpet shape. You've got a whole lot of variance on the right side. So this is not equal variance. Here's one that would be equal variance. It's roughly the same distance away from the line on top and bottom. This set of points has a little more spread than the other ones, but it's not enough to worry about. This one, however, it's really obvious that the variance is not equal. Now, one of the nice things about this chapter, this covers a lot, and I know it's different than what we're used to seeing, but one of the nice things is that if you see one of these problems on the AP test, a lot of times the problem will say, assume conditions for inference have been met. And so that saves you a lot of time from having to check all 5 of these conditions. There's a good chance that if you see one of these problems, you won't have to go through the time to check the conditions. Because, for example, equal variance, what I just showed you guys, you'd have to either draw the residual plot, which would take way too much time, or they would have to give it to you in the problem, and you could just look at it then. Linear, you'd have to look at the scatter plot and see, is it linear, is it curved? So a lot of times, like I said, they will say the conditions have been met. All right, so this section covers confidence intervals and significance tests. The confidence interval is a really basic formula. It's lowercase b, which stands for the sample slope, the slope of the sample that you're looking at, plus or minus the t-score times the standard error. And the t-score for slope problems is determined by the chart, the t-chart. But instead of degrees of freedom being n-1, it is n-2. And I've put that in a box because that's very important. This is the only time we see n-2 for degrees of freedom. So keep that in mind. The formula for the test, the t-score, it's always going to be a t-score, by the way, because obviously scatter plots are quantitative data, and we know that quantitative is a mean problem, so you're never going to do a z-score. It's always a t-score. It's really simple. It's lowercase b minus beta naught, or the slope from the hypothesis. Most of the time, the hypothesis is that the slope is going to be equal to 0, because if two things don't have a relationship, then their slope would be 0. But we'll talk about that more in the second video that I send you guys. The last thing you need to know for this video, you need to know how to read Minitab output. So let's look in the problems. All right, this comes from page 761, and here's a printout, a Minitab printout. Now, we've done this in the past. I think it was chapter 3, but just to go back over it, this number right here, top left number, is always the y-intercept, constant coefficient, Well, we know the y-intercept is a constant, so just remember the number across from constant is the y-intercept. The number directly below it is the slope of the sample. Now, the rest of the numbers on the top row, you do not need to know. We're never going to do anything with those three numbers right there. But on the bottom, these are important. Standard error coefficient 0.5712, that number is this number, and it is this number. So that's kind of important. You need to know that number for both of these formulas. Then this t, negative 1.92, this is really important. That t is this t. It is not this t. All right, this t comes from the chart, and we said you use degrees of freedom of n minus 2. But this t is always this t. And this p right here, this p-value, is the p-value that goes with this t-score. So looking at this formula again, b minus beta over standard error. Well, we said just a second ago that this number is almost always 0 in significance tests because you're testing that there is no slope, which should not come as a surprise because the null hypothesis we know is also called the no effect or no difference hypothesis. So if there's no effect, then the slope would be 0. So essentially, since this is almost always 0, the t-score is equal to the sample slope divided by the standard error. So sure enough, the sample slope divided by standard error, this number divided by that number equals that. Negative 1.0987 divided by 0.5712 equals negative 1.92. And that's going to be the case for all of these. Last thing I want to talk about in this video, this number, the standard error, that tells you how much you can expect the slopes to be different from sample to sample. This comes from just one sample that was taken. But if we took many samples, obviously the sample is not always going to have a slope of negative 1.0987. But we are anticipating that the slopes would fluctuate from sample to sample by about this much. All right, so that's what the standard error stands for. Now this number, S equals 7.97665, in case you've forgotten, because again, we did talk about this in chapter 3, but in case you've forgotten, this number tells you the average distance, the average vertical distance the dots fall from the regression line. All right, so how far the average distance is. And we know that the vertical distance is the residual. All right, a dot above the line has a positive residual. A dot below the line has a negative residual. So the average residual distance, that's what that S stands for. R squared, we talked about that in chapter 3. It's also in your throw-up list, so if you've got what that stands for, look it up in your throw-up list. R squared adjusted, you will never have to deal with that. So just forget that that exists. Forget that these three numbers, the top row, forget that those exist. You do need to know that. That is your y-intercept. This is your slope. And then I just went over all these. All right, so that is the first part of the section 1. I will send you guys a video probably tomorrow and go through either a test or an interval or maybe both. They're both pretty similar in how they're done. All right.